Okay, let's just jump right into this. There's this massive dilemma that I think haunts every single global logistics leader right now. They know security is a team sport. I mean, to build a truly resilient supply chain, you have to coordinate, you have to share risk intelligence and collaborate with everyone, the carriers, warehousing partners, customs agents. You need that collective intelligence.
It's completely non-negotiable, not in today's world.
Yeah.
Supply chains are, they're only as strong as their weakest link.
Hmm.
And detecting those weird events, is it sophisticated tampering or synchronized theft rings? That requires visibility across the entire chain, not just what's happening inside your own four walls.
But that's the wall they hit, right? The moment you ask them to share that operational data, we're talking precise vehicle movements, proprietary load tracking, route deviations. That's not just data. That's their competitive advantage. It's how they optimize, how they price. It's confidential. They just can't share it.
And that tension is exactly the problem we're tackling. This absolute need for collective intelligence versus the critical need for, data sovereignty. It's why the old centralized security models are failing. So today, we're diving deep into the two forces that are converging to solve this. First, the standard that guides all this, ISO 28000, and second, the revolutionary tech that makes it possible, federated learning, or FL2.
Right. And our mission today is pretty simple. We want to show you how federated learning doesn't just sidestep this data sharing conflict. It actually lets organizations jointly train these incredibly powerful collective machine learning models across all their data silos. It's like a technological shortcut to meeting ISO 28000's demands, all while keeping those competitive secrets totally safe. So before we get to the cool tech, let's set the stage. We have to talk about the rules of the road. ISO 28000, for anyone moving goods manufacturers, logistics providers, retailers, this is the benchmark, right?
It is. It defines the requirements for what's called a security management system, or SMS.
A SEMS, okay.
Exactly. And while it covers a lot, the part that creates our dilemma is its core requirement for a risk-based, systemic approach. To comply, you can't just secure your own little piece of the puzzle. You have to be able to identify risks in your supply chain activities. You have to systematically assess threats, vulnerabilities, impacts, and, this is the key, you have to manage that risk in coordination with your partners.
So it's not enough to just say, hey, we've got good locks in our warehouse stores.
Yeah.
You have to prove you're actively managing risk in a coordinated way across the entire chain.
Precisely. And that requires data. If you're trying to detect some new, evolving security threat, say a sophisticated pattern of cargo diversion or pinpointing vulnerable handoff points, you need visibility that goes way beyond your internal logs. The standard basically mandates collecting and analyzing data from all those external partners.
And boom, there's the wall again, the data island problem. Every single player has this rich proprietary data, the stuff that shows their performance, their efficiency, their secret sauce, and they will not and really cannot just upload all of that into some central database.
No, and it's a completely rational reluctance. Sharing that data erodes your competitive advantage, it risks regulatory penalties, it just invites attacks. So what you have is this globally recognized, standard, demanding, collaborative, data-driven risk assessment. But the very architecture of business competition and secrecy has created these isolated data islands. It makes that holistic risk assessment required by ISO 28000, well, functionally impossible.
Okay, so we're stuck. We need the coordination, but we can't share the data. Is there any tech out there that actually gets around this? And that brings us to federated learning.
Yep. FL is often called collaborative AI. It's a way to train a single, really robust machine learning model using decentralized data, meaning the raw data never, ever leaves the local source. It was engineered specifically for this kind of problem.
That sounds a bit like magic. So if, say, 1,000 different partners are all training one model, but they aren't sending their records, what are they sending?
They're only sharing the results of their training, the learnings. Think of it like this. You've got 100 students, each studying a different part of the world's supply chain. They all study locally, with their own private notes. Instead of asking them to send you their raw notes, which have all their secret details, you just ask them to send you a little summary of the patterns they observed.
Ah, so the students are the local clients, and the summary is the model update.
Exactly. Technically, they're sharing the model's parameters, gradients, and weights. These are just numbers that represent the relationship between inputs, like route and time, and the outcome, like the risk of tampering.
Wait a minute, though. If they're sending those numerical updates, the gradients, couldn't a really clever hacker or competitor just reverse engineer that to figure out the raw data that created it?
That is an excellent question. And you're getting right to the heart of it. While model updates are a lot safer than raw data, you're right. Sophisticated attacks like model inversion attacks can sometimes infer sensitive stuff from the gradients.
I knew it.
Which is why true enterprise-level FL, especially for high-stakes stuff like this, adds more layers of protection. We call them privacy-enhancing technologies, or PTTs. Things like secure multi-party computation or differential privacy.
Okay, break that down for us. What does differential privacy actually mean here?
It means you add a tiny, mathematically precise amount of statistical noise to the model updates before they get sent. It's just enough noise to make it impossible to trace back to any single data point, but not so much that it ruins the overall accuracy of the big model.
Wow. So it's not just distributed training, it's mathematically guaranteed privacy on the information being shared. So entities get the benefit of collective intelligence, a much smarter model, while keeping their data sovereign. That's what breaks down those silos. That's what ISO 28000 needs. Okay, let's get specific. How does this amazing tech actually help a security manager tick the boxes for compliance? We know ISO 28000 has these specific elements. How does FL map to them?
We can map it directly. Let's start with the foundation. Context and risk assessment. The standard demands you understand the risk environment across the whole chain. With FL, multiple parties contribute their localized insights, delay patterns, regional theft methods through model updates. No raw data is shared, but the resulting aggregated global model gives you this panoramic view of supply chain risk that no single firm could ever see on its own.
So instead of manually compiling static risk reports from partners, which are probably outdated by the time you get them, you get a continuously updating machine-learned global risk map. That's more than just identifying risk. That's informing what to do next.
Absolutely. And that ties right into the next part. Implementing controls and processes. Once that federated model predicts a spike in cargo tampering on a specific route, that insight immediately informs your control design. You might increase GPS monitoring on those units, or maybe mandate dual driver teams for that leg of the journey. The point is, your controls become data-driven and predictive, all while preserving everyone's confidentiality.
And there's always performance evaluation and monitoring in these standards. You have to prove it's working.
Right. And because the global model is always running, it generates objective, data-driven outputs, things like risk scores, anomaly flags, trend analytics. Each partner gets insights tailored to them from the collective intelligence. This gives them the auditable, metric-based evidence they need. They can literally track how well their new controls are reducing the risks that the model flagged.
And finally, the cornerstone of any ISO standard. Continual improvement, the whole plan, do, check, act cycle.
FL is inherently adaptive. It's not a static, rule-based system. The model is designed to learn as new data comes in and new updates are shared. This continuous learning cycle is a perfect mirror of PDCA. It ensures the security management system is always dynamic and always improving its intelligence.
Okay, this all sounds like the ideal solution, but I know that implementing multi-party AI is, well, it's rarely simple. If an organization wants to make this real, what's the roadmap? What are the first few steps they absolutely have to get right?
It's funny, the first hurdle isn't technical, it's structural. Step one is absolutely critical. Stakeholder alignment and governance. You have to get formal buy-in from every key partner carriers, warehouses, maybe even customs. And you need a solid governance framework that spells out who manages the aggregator, who audits the process, all of that.
That sounds like a massive political hurdle. You're asking direct competitors to agree on a shared system.
You are. But you're appealing to a shared need, security and compliance. Once that's settled, step two is the technical blueprint, model objective and data schema. All the partners have to agree on the exact goal. Are we predicting delays or theft? And, crucially, they have to standardize the features, the input data points that will feed their local models.
Hold on, so if one partner measures temperature in Celsius and another uses Fahrenheit, how does the model make sense of that?
It can't. That's exactly the point. The local data stays private, but the schema, the format and definition of the data has to be standardized. That ensures that when the model updates get aggregated later on, they're all speaking the same language. After that comes step three, the local data prep and privacy safeguards we talked about. This is where you actually install the software and make sure things like differential privacy are working correctly.
And the technology handles the aggregation part.
It does. Step four is the federated training cycle. A central server orchestrates rounds of training, updates are sent, securely combined, and the new, smarter global model is sent back out. This repeats until the model is accurate enough for the security goal.
And then how do we close the loop back to the security manager?
That's step five, insight extraction and control design. The output, the risk scores, the hotspot identifications is used by each partner to update their internal controls and procedures. And finally, step 6 is just monitoring, audit, and improvement. You track the model's accuracy, audit against the ISO standard, and use feedback to keep making it smarter. It's a continuous loop.
We've painted a really compelling picture here. The benefits are clear. You get collective intelligence without sharing data. You meet the ISO mandate. You keep your competitive edge. But where does reality hit? Where do organizations struggle the most when they actually start doing this?
The benefits are, yeah, they're transformative. But the challenges are significant, and they're mostly technical. The number one hurdle is dealing with heterogeneous data. In technical terms, it's called non-IID data, non-independent and identically distributed.
That's a mouthful. Can you put that into a supply chain context for us?
Sure, non-IID just means the data from each partner looks really different. Imagine one partner mostly moves cold chain pharmaceuticals from, say, Europe to Asia. Their data is full of temperature logs and high-value theft risks.
Got it. Very specific.
Now compare that to another partner who just moves huge amounts of dry bulk commodities like coal or grain, all within one country. Their focus is on large-scale delay risk.
Their security risks, their data, the fraud indicators, they're completely different worlds.
Exactly. And if you just average the model updates from those wildly different data sets, you might get a terrible model that's good at predicting neither. The model performance can really suffer. Overcoming that non-IID problem takes very complex algorithms and careful engineering. It's a major challenge.
That makes perfect sense. The model gets confused if the partners are too different. What about other challenges?
Well, beyond that, you need a robust technical infrastructure. You can't run this on just any old cloud storage. You need specialized FL platforms that can manage the training grounds, handle the complex encryption, and guarantee uptime. That's a big upfront investment. And finally, that organizational hurdle never fully goes away. You need ironclad legal agreements before you even start, which can be a very lengthy process. So to synthesize all this, the message for the logistics sector is really clear. The modern supply chain requires standards like ISO 28000 that mandate proactive collaborative risk management. Compliance isn't optional anymore. Federated Learning provides that essential technological bridge. It lets organizations build these incredibly intelligent collaborative risk models while definitively protecting their own data.
So what does this all mean for the future? We're moving past this era of reactive security, of these isolated data islands. Supply chain actors who can deploy FFL get this dual advantage: enhanced resilience and verifiable compliance. They are moving toward a future of truly intelligent, standards-driven logistics. And just think about the broader implications here. If an industry as complex and competitive as global logistics can solve this tension between secrecy and collaboration, where else could this model-sharing, data-protecting approach completely transform an industry? That's a powerful idea for you to consider.